Okay, I'm going to attempt to do a video as I show the problem. This could cause some issues, but we'll see. Because sometimes on Piecewise you need to see while I'm doing it. So I see that the left portion, which is the first one we see, is really just y equals -3. It is a horizontal, and I'm just going to use H for that, ray, and I'm just going to use R for that, to the left. So this is a horizontal ray to the left. So I'm going to draw a horizontal segment, and since I said to the left, here's my left hand. So I'm going to put the arrow on the left hand. Notice it has the equal sign, which means that the endpoint is included. And I can figure out my endpoint, which is 0, because that's the x value. Remember, x is first over here, and y, this is backwards. And so I have -3. So I can come over here and plot 0, -3, and it's closed, and I can draw a horizontal segment to the end like that. Or I can stop, or I can put an arrow on it. Your calculators don't have any arrows or anything. But notice down here, this says that, oh, I want the limit as I approach 0 from the left. Well, as I approach from the left, that's -3. So this is -3. Now moving on, I'm going to do the next one. And this, the bottom half says that I want to be greater, which means from the right. So I'm a horizontal ray again, because this is nothing more than y equals 3. But now I'm going to the right, so horizontal ray right. And I can draw a picture of it. There's a horizontal line. This is the right side, so here is the arrow. I don't see an equal to, so it's an open circle. That's not a hole. Remember, an open circle is different than a hole. And so I know my ordered pair is 0, 3. Now this one is open, and I forgot to mark this one in as closed already. So I'm going to plot my 1, 2, 3, 0, 3, and I want to go to the right, and I can take it to the end of the paper. I can put an arrow. I was always taught you needed an arrow. I accepted either way. What you need to know is when you go to college, do what your professor says. This says I want to be, the limit as x approaches 0 from the right. Well, the right side is 3. So this is 3. So what do I see here? I see that these two are not equal. So that immediately tells me that I have a jump, because they're real numbers and they're not equal. And this is D and E. And what is my function value? Well, what was the endpoint for the equals to? It was 0, -3, so the function value is -3. So this is similar to your problem 1. So now let's go and see something that's going to be similar to problem 2. Now, my graph paper doesn't match yours. I couldn't find that at home. I just had the 8x8 squares, not the 10x10 squares. So anyway, let's continue as we do this one. I want to be the, look at this graph. It's an oblique line. What do I notice? I notice this is the line y equals x plus 2. I notice that the slope goes uphill, but I want the left side, which is here, so that's my arrow. I look over here, it's equal to, so this one will be closed. And when I look at this, I'm going to say it's an oblique ray, and it's going to be heading left, oblique ray left. What will the endpoint be? -1, and when I insert -1 here, I get 1, and that will be a closed circle. And so plotting -1, 1. Now notice this is the imaginary division line because I'm changing it at -1. So right in here, I'm only going to take half and then I'm going to do half. Now, I use slope when I do this, but you could simply put in -2 and say, oh, I'm going to plot 0. There I am, and now draw your ray to look just like this, endpoint all the way down. Or you could come up here and check out what is slope. Well, the slope is 1/1, but that's when you go right. When you go left, what's the slope? Down 1, left 1. Notice when I go down 1, left 1, I get the same point. And if I wanted to, I could just keep doing a whole bunch of them. I can stop and just draw my arrow, or I can go all the way to the end of the graph and leave the arrow off. But as I approach -1 from the left, this will be an x plus 2. -1 plus 2 is 1. Notice it matches the endpoint every time. So now let's consider what's happening on this side. Well, again, it's an oblique ray, only this time it's heading to the right because it's in that position. Notice the slope is negative. This is the right side, so that's the arrow, and that's open. So over on my graph, it's going to look like this somewhere along the line x equals -1. When I insert -1, don't be a gobble gobble. 2 minus -1 is 2 plus 1 is 3. So I plot -1, 3 as an open circle. And then again, I can plug in the point 0, and when I plug in 0, I get 2. I could plug in 1 and I get 1. I could plug in 2 and I get 2 as long as they are on the right. Or I can do slope, and the slope is -1/1. And since I am, moving to the right, I want to go down 1, right 1. Well, notice down 1, right 1, down 1, right 1, down 1, right 1. This is matching. And so I do the limit as I approach -1 from the left. And of course, the function value there, the function there is 2 minus x. And 2 minus -1 is still 3. It will still be that value up there. But notice, these are two real numbers. They're not equal, so this is a jump. And this is D and E. And you can see it's a jump, because if I filled in that circle, they're not connected. That's how you can tell a whole. And what is f of -1? Well, it matches the one on the top, and so it's going to be 1. And then the third and final problem that you have will be similar to this. Remember, these aren't the exact problems, but they're pretty darn close. I'm going to give you a parabola. And when we start out, let's look at the parabola. Whenever I have a parabola, I want to know its vertex. And its vertex is 0, 0. But anyway, this is going to be a parabola or a parabolic ray. And it's going to go left. And the endpoint's going to be 2. And 2 squared is 4. And it's open. But notice, when I look at the number line, over here is 2, 1, 0. So if this is the vertex, but I get to start here, I'm going to want the left side, but I'm going to get more than half of my parabola. So I'm going to plot my 2, 1, 2, 3, 4 as an open circle. I always plot my vertex if it's available. I can use symmetry and get another point, and that's all I need. But most of you can't help yourselves. You say, if this is 2, I'm going to plug in 1, and I'm going to get 1 and 1, just because it makes it easier to draw. And notice you could keep going up like that and not choose to put the arrow on or choose to put the arrow on. But if you don't go all the way to the end, you must put an arrow. So anyway, the limit as I approach 2 from the left, well, the function f of x is x squared there is 4. And remember, here is that magic line where I want this part of the parabola and this part of the oblique line. So now I'm going to come to my oblique line, and my oblique line, notice, has negative slope. So I'm going to draw a ray down. This is the right side, so it gets a right arrow. It says equal to, so it's going to have this vision. My slope is -1/1 because I'm going right, so I'm not going to rewrite that. This is an oblique ray right. The ordered pair is 2. 4 minus 2 is 2. It's a closed circle. So I can just use slope. I'm going to come over here and plot 2, 2. Now I could plug in the number 3 and 4 and 5 and find answers, but doing slope, down 1, right 1, down 1, right 1, down 1, right 1, do as many as you want. And again, you can do this, draw the arrow. I started missing. That was supposed to end up down there, but oh well. It's what happens when you do things live. And so the actual function here is this. I get 2. Again, I see these numbers are not equal to each other, so I know it's a jump. This doesn't equal that, so it's D and E. And the function value is actually the one at the bottom, which is 2. So this is how you're going to do page 1. And what it is, you already know how to do the limits without looking at the picture. You know how to look at the picture and do the limits. What we're trying to do is tie it all together where you can do it algebraically, you can do it graphically, and then with these explanations, you can talk about it by saying words. And so technically, this is analytically. The only thing we haven't done with this out of the 4 things where we want verbal, analytically, algebraically, that's the same thing, numerically, and graphically, is we didn't do numerically on this one. So endeth video 1.